Hello everyone. So today we are going to start with quantum computing. This is the first video of the series. So before starting with big concepts and mathematical part, we must know what is quantum computing and why do we need it over classical computing. What purposes does it solve? So as we know it from classical computing, a bit can have two values, either 0 or 1. But think of it just if we had more bits. For example, in a decimal system, we can represent a big number easily as we have 10 discrete values from 0 to 9. But in binary system, we have only 0 and 1, which makes it very difficult to represent big numbers. But now we can't change it because computation has already been created. But I can tell you one thing, in quantum computing, this is very much possible. In quantum computing, a bit is called as a qubit, where by just using 2 bits 0 or 1, we can actually represent more than 2 values on a single bit. This is called as superposition, or I would say a phenomenon of superposition, which can help us in representing a bit in different states at the same time. So this might sound weird, but this is possible by superposition. So what is actually superposition? Superposition is a phenomenon of physics. As we know it from our high school physics, that a body of mass m is moving with a velocity v, then in t time it will cover a distance of vt and we can determine its exact position, and we can even predict the future that at after time t or t1 at which position it would be. But this is not a case in quantum world. In quantum mechanics, for example, a particle like electron moving at a very high velocity, the position of that particular particle cannot be determined. Only a probability curve can be drawn and the probability of finding that particle at a particular position can be determined. This can be done by a wave function. So wave function is basically the Schrodinger equation, which a scientist named Schrodinger discovered. This is the function, as you can see, it is a function of time and space, which actually gives a probability of finding a particle at a particular position. So what is actually this? So you might know this equation, which is called the de Broglie's equation, in which the wavelength of a particle moving with a momentum p can be determined by this formula, where we can divide the Planck's constant by the momentum of the particle and we can find what particular kind of wavelength or what wavelength does that particle have. This basically shows that every particle has a wave character, but particles like even us or earth or big particles have very less momentum as compared to their mass, so they doesn't show a significant wave character. But in quantum world, particles like electron do have this significant character. So this was about physics, but how do we imply this concept in quantum computing? So this was the idea that I was telling about a qubit, where a particular bit can be represented in a superposition state or a mixed state of both 0 and 1, where you can see this, that representation might look weird, what kind of symbol this is, but I'll be telling it later. For understanding, you can understand that alpha and beta are basically the probabilities of being in a particular state. As you can say that a bit is in 0 state with a probability alpha and with probability beta in 1 state, and the sum of these probabilities will be equal to 1, as it can't be more than 1. So this is a basic thing. So this is the basic idea of quantum computing, that we can represent a bit in a superposition state, and where it doesn't have an absolute value of 1 or 0, it actually has a mixed state. It has probability of being in 0 and 1 as well. This might sound weird, but I will be explaining it more in the upcoming videos. If we look at basic differences between classical and quantum computing, then we can see that it is represented by a bit, and in quantum computing we have qubits. It has a 0 or a 1 state, but in quantum computing we have a mixed state of 0 or 1. Boolean algebra is used in quantum computing, that are OR gates, AND gates and NOT gates, but in quantum computing we use linear algebra, which means that all the qubits will be represented in a form of a matrix and all the gates will be applied in form of a matrix, that I'll be elaborating in upcoming videos. In classical computing, the state of a bit is deterministic, like we know by surety that a bit is in a 0 state or a 1 state. But in quantum computing, that's not the case. We always have probabilities of being in a particular state, same as an electron. So this was the basic idea of quantum computing. I hope that you got a rough idea what it is about and how it works. And please stay tuned to the channel, watch the upcoming videos of the playlist so that you understand this from scratch. Thank you.